Ants are one of the most dominant terrestrial species on the planet, navigating our world with a machine-like precision that belies their small scale. Understanding the secret to this global success requires looking past their social behavior and zooming directly into their hyper-optimized microanatomy. The Allegheny mound ant possesses a specific biomechanical solution for heavy lifting, a soft tissue neck joint bridging the stiff exoskeleton of the head and thorax. Ohio State researchers used micro-CT scans to build this mesh model, testing the joint's limits. It withstands loads 5,000 times the ant's weight. This strength is directional, maintaining integrity only when the head perfectly aligns with the downward load, distributing stress across the legs. This anatomical optimization is so advanced that engineers are now analyzing it to develop the next generation of ultralight robotics and assistive devices. This engineering precision extends to the environment the colony builds. Beneath the surface, ants construct deliberate, complex architectures. This diagram shows the structural units of a nest, descending vertical tunnels connecting to horizontal chambers. These geometric arrangements are optimized for climate control. The shape naturally draws in cool air and exhausts heat, maintaining a stable environment. Human architects are now studying these subterranean layouts, attempting to biomimic their natural cooling properties for sustainable high-rise buildings. To understand how millions of insects coordinate these complex designs without a master architect, we have to look at the colony through a different biological lens. Biologists often view the colony as a superorganism, a single living entity where individual ants function like expendable cells, driven by shared chemical signals. Because individual lives are cheap and entirely replaceable to the superorganism, these colonies can engage in systemic group-on-group warfare. Army ants utilize a shock and awe strategy, moving in a tight phalanx to overwhelm rivals. They rely on Lanchester's square law, where superior numbers allow a group to win a series of simultaneous small-scale fights. Marauder ants utilize a specialized division of labor. As this study detail shows, they deploy their smallest liner workers as foot soldiers to the most dangerous zones of contact. These miners act as a sacrificial barricade, using their jaws to grab and hold the limbs of an enemy. They pin the target in place until a major worker, some weighing 500 times as much as a miner, arrives to deliver a terminal bite. This absolute lack of individual self-preservation creates a force that never retreats, utilizing attrition tactics that maximize the colony's collective power. Other species prioritize strategic territory over blunt force. Weaver ants maintain massive perimeters in the forest canopy, often spanning several trees. They manage these huge spaces by aggressively defending architectural choke points, like the specific spots where a tree trunk meets the ground, effectively locking down the terrain. Slave-making ants take strategy even further, utilizing chemical subversion to raid colonies that significantly outnumber them. They deploy propaganda chemicals, a targeted biological weapon that throws the defenders into total disarray. The confusion prevents the larger colony from organizing, allowing the invaders to plunder the nest without a physical fight. Across millions of individuals, these maneuvers are executed flawlessly through an invisible network of pheromonal communication. These superorganisms reach their most extreme scale when they spread globally, forming colonies that span entire continents. In California, a single supercolony of Argentine ants forms a unified nation of 1 trillion individuals. It stretches hundreds of miles, sharing one chemical identity. At these borders, the fighting never stops. Millions die monthly in a continuous, century-long trench war with no settlement. That single ant on the sidewalk is a microengineer, a sustainable architect, and a foot soldier in an invisible, world-spanning civilization.